Hash tables are an important type of data structure which is designed to use a special function called the hash function. A hash table is used to store keys and value pairs. It uses a hash function to compute an index into an array in which an element will be inserted or searched. They are good at storing data in sets made up of keys and values. In our case, a name is considered as the key and a gender is the value. As an example, let's imagine the data in the diagram is stored as an array. We prepared 6 boxes for the array and stored data in them. Now let's imagine looking up Elsie's sex. We don't know what number Elsie's box is in the array. Thus, we need to search in order from the beginning. This operation is called as linear search. The key for the data stored in box position 0 was Lennon, which isn't Elsie. Box position 1 wasn't Elsie either. Box position 2 wasn't Elsie either. Box position 3 wasn't Elsie either. The key for the data stored in box position 4 matched the key Elsie. By extracting its corresponding value, we learn that Elsie's gender is female, denoted as F. In this way, the linear search operation carries a cost proportional to the size of the data. It takes time to search through data when it's stored in an array, making it an unsuitable choice. A hash table solves this problem. We will prepare an array to store same data. For convenience, we will have 5 boxes in an array. Now let's store some data. When storing the data of Lennon, we calculate a hash value for the key using the hash function. The result obtained in this case is 4928. It's a function that converts data into a value of fixed length. The hash value sought is divided by the number of boxes in an array, 5, to find the remainder. The operation that finds the remainder of a division is called the mod operation. It resulted in a value of 3. The data of Lennon is stored in box 3 of the array to match the result. This operation will be repeated to store the other data. When storing the data of Lisa, we find the key's hash value and perform a mod operation on it using the number of boxes in the array 5. The result was 1. The data of Lisa is stored in box 1 of the array. When storing the data of Gates, we find the key's hash value and perform a mod operation on it using the number of boxes in the array 5. The result was 4. The data of Gates is stored in box 4 of the array. When storing the data of Mellon, we find the key's hash value and perform a mod operation on it using the number of boxes in the array 5. The result was 1. When we try to store the data of Mellon in box 1 of the array, the data of Lisa was already stored there. When something like this happens, it gets connected to the existing data as a list. There are several types of hash table structures, but the method that uses lists is called the chain method. When storing the data of Elsie, we find the key's hash value and perform a mod operation on it using the number of boxes in the array, 5. The result was 3. Because the data of Lennon is in box 3 of the array, the data of Elsie gets connected as a list. When storing the data of Jobs, we find the key's hash value and perform a mod operation on it using the number of boxes in the array 5. The result was 3 again. Because the Lennon and Elsie data are in box 3 of the array, the data of Jobs will be connected as a list. All the data is finished being stored and the hash table is complete. Let's imagine looking up Gates' gender. In order to find out what box of the array Gates is in, we find the key's hash value and perform a mod operation on it using the number of boxes in array 5. The result was 4. The key for the data stored in box 4 of the array matched Gates. By extracting its corresponding value, we learned that Gates' gender is male, which is denoted as M. Let's see what happens when we look up Elsie's gender. In order to find out what box of the array Elsie is in, we find the key's hash value and perform a mod operation on it using the number of boxes in the array 5. The result was 3. The key for the data stored in box 3 of the array was Lennon, not Elsie. How could we handle this? So, a linear search is performed on the list starting with the data Lennon. Data with the key Elsie was found. By extracting its corresponding value, we learn that Elsie's gender is female, which is denoted as F. As you can see, by using the hash function, hash tables are able to quickly access data within an array. When hash values overlap, lists are used, making it possible to flexibly handle an uncertain amount of data. When the size of an array used by a hash table is too small, the overlaps increase, making linear searches more prevalent. Conversely, if the array size is too large, there will be many boxes with no data stored in them, wasting memory, so discretion is needed. Hash tables, with their flexible data storage and fast lookup, are used in the associative arrays of programming languages. This concludes the explanation of hash tables.